On October 25th, the organization OpenSSL sent out an advisory with a software update, saying that it was fixing a critical security vulnerability, and that they would be releasing details the following week on November 1st. In that intervening week, hopefully most users updated, and then the following week when details dropped, it had been reduced from a critical security vulnerability to a high. And that got some people annoyed, the process was a little bit confusing, and it impacted lots of people across the internet. So, what is OpenSSL? Does this impact you? Should you care? And how does this fit into the broader discussions of supply chain security? My name is Eldridge, I've got more than a decade of experience in information security and IT, and today I'm going to break down OpenSSL, software libraries, and the concept of supply chain security. So first off, what is OpenSSL and what are software libraries in general? So when you're building software, generally you are going to depend on libraries from other developers for specific functionality. For example, if you're building an app that deals with users all over the world, you might need to deal with time zones. And rather than figure out all of the time zones in the world and write some software to handle it, there probably already exists a piece of software to handle time zones in the language you're using. And so you would simply import that library. OpenSSL is one of these libraries. It actually does cryptography. So OpenSSL is responsible for encrypting and decrypting things. So an example of how you might see this being used is in HTTPS. OpenSSL is less popular today than it was a decade ago, but it's still very popular on the internet. And if you go to a site using HTTPS, it's probable that on one end of the connection to the other, OpenSSL is the piece of software being used to handle that transaction. So the potential for who was impacted by this is very, very broad. And so the question that people often tend to ask is, well, who got hacked? And the answer is, hopefully, possibly, no one. And this comes down to the difference between a vulnerability and a breach. A vulnerability is where an attacker conceivably could attack. A breach is where an attacker was successful. So an analog to, say, your home is, let's say you leave one day and you don't lock your door behind you on accident, and you come home at the end of the day and nothing has been stolen or messed with in your house. That is a vulnerability. Someone could have stolen your stuff very easily that day, but did not. Whether it was because no one noticed or because they did notice and chose not to, we don't know. A breach would be if, whether or not your door was locked, your stuff was stolen. So that's the difference, and in the case of this OpenSSL issue, it seems to have been a vulnerability. There does not seem to have been evidence that it was used in a breach as of yet. And vulnerabilities in software are often introduced from upstream. So going back to what I mentioned earlier with the different software libraries, when you are making a piece of software, the software libraries that you use are what's called upstream. And there's so much software being written and so many people depend on so many libraries that unless you are a large organization with lots of resources, it's very difficult to vet every single library that you use everywhere in your organization. So a lot of folks will depend on the security capabilities of their upstream providers. So lots of folks using the OpenSSL library were not vetting it for security, but depending on OpenSSL to do that for them. Until now, they have actually had this vulnerability in their software that they built using OpenSSL. Again, there doesn't seem to be any evidence that this was actually used in a breach anywhere, but it was a security vulnerability introduced from upstream. And now OpenSSL is just one example of a software library. And as you might imagine, because it does the encryption and decryption, it's a very important one, and having a vulnerability in that library is very significant. But vulnerabilities and even other issues can be introduced from any library. One example that I like sharing is there was a piece of software called LeftPad. And this was a relatively short piece of software. What it did was ensure that web pages could be aligned in a way that the creator wanted. And eventually, the author of LeftPad decided they didn't want to deal with that software anymore, and so they deleted LeftPad. Now, lots of website developers using that library had it set to auto-update, so as the LeftPad author released updates, security or otherwise, their site would automatically update their version of LeftPad. So when it was deleted, lots of these sites automatically updated to the non-existent LeftPad, so just empty code, breaking lots and lots of web pages across the internet. So that was not really a security issue as much as it was a usability one, but you can see how the same thing might apply, where something happens upstream and it gets updated across many, many places on the internet without somebody necessarily noticing. Now, this has happened before. Several years back, there was another OpenSSL vulnerability known as Heartbleed. And at this time, Google and lots of other major organizations and companies were using OpenSSL to manage their HTTPS connections. And OpenSSL at that time, despite Google being a huge and profitable company, OpenSSL that they were using for all of their HTTPS was a small organization where only a handful of employees were paid full-time to work on OpenSSL. Now, when Heartbleed was discovered, what Google did was turn around and make a much smaller cryptography package from a dedicated team, and they called it Boring SSL. And this is one that you can actually go and download and use today if you would like to use that instead of something like OpenSSL. And this has been a continual problem in the industry. Lots of these libraries upstream and lots of these open source pieces of software that folks depend on are not necessarily well-funded or well-staffed. There are some that are very well-known and well-funded. One of these is Linux. It's used on almost every server that's on the internet. It's used in phones, it's used in routers, it's used in laptops, all over the place. The Linux Foundation pays the creator of Linux, Linus Torvalds, and others to continue to develop and secure this product. Other large organizations that depend on Linux sometimes contribute money, or sometimes they contribute their own developers to working on the code, and oftentimes both, because of how crucial and critical Linux is in the broader internet ecosystem. But not every library and every piece of software has the reach and popularity of Linux. OpenSSL, as I mentioned a few years back, only had a handful of full-time employees despite being the basis for most of HTTPS on the internet. And even that was a pretty significant package. Going back to something like LeftPad, that was introduced and just caused chaos when it was deleted, but didn't really cause security issues. But you can imagine if the creator had wanted to introduce security issues into thousands of sites across the internet, that might have been easier than people would hope. And this is just assuming that security vulnerabilities are introduced by mistake or accident. Lots of open source pieces of software accept contributions from anyone who wishes to contribute. And they tend to be vetted, but that doesn't necessarily mean that someone that is attempting to contribute malicious code can't get it into a library that is then distributed to thousands of packages across the internet. And this is what people are talking about when they refer to supply chain security. It's where all of the upstream packages and the upstream of the upstream of the upstream are introducing all of these dependencies and attack surface into the final product. And just getting your arms around all of that is a challenging and difficult task. There are a few options here that different companies and organizations have experimented with. One of the obvious ones is just build all the software yourself. You don't have to worry about upstream if you are the upstream. However, one of the great benefits of using all of these libraries is you are able to iterate and deploy very, very quickly. You don't have to spend time researching and learning all about time zones when you can just import a time zone library. You don't have to understand and learn all the mathematics behind cryptography just to use HTTPS. You can import these libraries. So, while that would be one way to do this, it's not really tenable for most people or organizations. Another one would be to vet incoming software as it's imported. This is something that larger organizations do before a library can be used. It has to be vetted both by security and sometimes by legal to make sure that the software licensing is something that the company can use. And then the third one is just letting the upstream library maintainer be the one who determines the security for that library and hope that they get it right. A lot of companies will use a mixture of 2 or 3, The more funding and more security conscious a company has, the more they're going to try and vet any piece of software that comes into their infrastructure. The smaller companies, or the ones with less resources, will oftentimes try to be very conscious about what libraries they are using and make sure that they are using widely known and dependable ones, but they may not be doing thorough vetting. They may just be depending on a smaller set of libraries that they trust, and that they trust the upstream developers to continue to update and secure appropriately. So that's supply chain security with OpenSSL and software libraries. That's just kind of a brief overview, and that kind of gives you insight into what people are talking about when they talk about the broader supply chain issues. So I'll be talking some more about some broader industry things as they happen. I'll also be having a video coming out soon about passkeys and other cutting-edge authentication technology. Also, I'll be making videos about lots of topics, so I've got a pretty big backlog, but feel free to drop something in the comments if you want me to do an explainer video about that. Once again, my name is Eldridge. If you like this video, please remember to like and subscribe, and also go to your friend's house when they're not looking, open up YouTube on their computer, and like and subscribe there too. See you soon.